y is equal to sine x. So we want to find the inverse function. How we can find? So to work here analytically, let's say we have a y is equal to the sine x. So let me rewrite again. If we want to find the inverse function analytically, whenever it's x and y, we are going to interchange. Instead of the x, instead of the y, I'm writing x. And here is a sine y. And now I'm taking the inverse of a sine both sides. If I'm taking the inverse of the sine both sides, we are going to have this way. Inverse sine of x is equal with the sine time inverse of the sine minus 1 and is a y. But the sine times sine minus 1, so just this one here. So let me write a bit different color. Just this product is going to be 1. And 1 times y is equal with y. So now y is going to be sine minus 1 of x. And the last step here, instead of the y, we are exchanging with the denotation f on exponent minus 1 of x. And so just let me take this out here because it doesn't look very good. And now f of minus 1 of x is going to be equal, so just I am exchanging this denotation with the inverse denotation, and is a sine minus 1 of x. So this is inverse function. But here we don't know exactly what's going on. But first of all, let me draw the sine function. And if I'm drawing the sine function is going to be approximately this way, and is going to positive infinity. And we know those critical points. Here are a pi, 2 pi, and here is a pi over 2. Okay, and this point here, critical point, and this 1. And I'm looking for critical points. And this is going to be, for example, 3 pi over 2. 3 pi over 2 is, and is a minus 1. And it continues forever. But in the other side is going the same thing. So it's going to continue this way. So here is a 0, and here is a minus pi over 2, and minus 1 at this point here. And this point here is a minus pi and 0. And here is a 3 pi over 2, and is 1. And it continues up to minus infinity. But now we already know geometrically, if we want, for example, to find the inverse function, we have to find the symmetrical side of one side with the other. But here, in a whole the interval, this function cannot pass the horizontal test. Therefore, we have to restrict the domain. But first of all, let me write here the line y is equal with the x. So the line y is equal with x is going to be something this way. Okay? So it's not by hand, it's not on scale, but approximately it's going to look something like this. So y is equal with x. And in the function y and the inverse function, they have to be symmetrical one with another. But what can pass the horizontal test? If I'm restricting the domain from minus pi over 2 to pi over 2 to this point here, if I'm restricting the domain, if of course if we are doing, for example, a vertical test, is going to pass, but also is going to pass the horizontal test. This function is going vertical test to pass everywhere, but the horizontal test is a problem. So, but if I'm restricting from minus pi over 2 to pi over 2, if we are doing the horizontal test, is going to pass. So, just in this interval, it has the inverse function. Now, the inverse function, what is going to be the inverse function? I know exactly. This has to be the symmetrical. So, this point here has to be symmetrical with this point, and this point is 1 and pi over 2. And now, this is going to be something like this. And in the other hand, if here is a minus pi over 2 minus 1, and this point here is going to be symmetry, the same distance from here to here, same distance from here to this point, and this point is going to be minus 1, and minus pi over 2. And this is going to be something like this. Probably it's not a very good, this what I draw here by hand, but if we want to, for example, to see the inverse function a little bit better, we can go in the Desmos and we can draw it. And in Desmos it looks something like this. So here is a much beautiful picture. So we have the function, but now here is with the red function. This is a sine x, and the inverse function f of minus 1 of x s minus 1 is the blue one, is this part. And we already see is similar what we did, but here is on scale and looks much more beautiful than what I did it here in this case. So we can see here sketching, and we can see here on the scale the inverse function. So the inverse function is just in the restricted domain because it doesn't have other domain. Is not in whole out of the domain. The inverse function does not exist, but it exists only from this position here, from a minus pi over 2 if we are restricting the function to pi over 2. So just in this interval.